Okay, so yesterday we went and we looked at graphing to find the solution to a system of equations. And we looked at classifying them. If we have parallel lines, there's no solution. If we have the same line, there's an infinite number of solutions. But if we have two lines with different slopes, then they have one solution. And what we're going to talk about first of all is how we can use substitution. So reminder, if we use substitution when we're going to replace something, when something is equal to one thing, I can replace it with that. So we're going to do that with solving this system. So instead of graphing, we're going to look at it by using substitution and then something that we call elimination. So here we want to solve this system of equations. Y equals x minus 1 and x plus y equals 7. So when it says to use substitution, that means we want to make it so that we have one variable and we're going to use what we know about the other variable to get rid of it. So in this case, we've got y equals x minus 1 and x plus y equals 7. In both these cases, we have two variables. If I'm solving equations, how many variables do I want? One. Okay? So I can take this equation here because it says y equals x minus 1, and that means that the y and the x minus 1 are equal. They both represent the same thing. So then I can, down in the other equation, I can replace this y with x minus 1 and solve it. So we get x equals 4. Okay? Well, since we're solving a system of equations, we're looking for the point where they intersect. Well, this gives me the y-coordinate, or the x-coordinate. Now I need to find the y-coordinate. So I'm going to take that x equals 4, and I'm going to put it in here then for x to find the value of y. So my answer then is going to be the point 4, 3. So if I graph both of these lines, they would intersect at the point 4, 3. So we're doing substitution. We're solving for one of the variables, find out what it equals, and then substitute that into the other equation and solve. So we want to take where we've had two variables, make it into one, so I can find the point where these lines intersect. Sometimes when we get the equations, that they're not written out, x equals this or y equals this. So what you need to do then is that you're going to have to either solve for x or y first, and we want to do whichever one is easier. So if I look at these two equations, which equation and which letter would be easiest to solve for first? Okay, the top one in x. All right, so we're going to take the top equation, 2y plus x equals 4, and solve it for x. So we'll subtract 2y from both sides. So x equals 4 minus 2y. And it does not matter whether you put the y first or the constant first. It's up to you. Okay? You don't have to do y equals mx plus b type thing. Okay? It doesn't matter. So now, since x equals 4 minus 2y, then I'm going to replace this x here then with 4 minus 2y. And then I have an equation that just has one variable instead of two. Well, if I put it back in here, I wouldn't get anything. I have to use the other equation then. Okay? Once you solve one equation, then we have to put it in the other one. So we have 3 times 4 minus 2y minus 4y equals 7. And we're going to solve that equation. So y equals 1/2. Now once we know what y equals then we'll take that, we'll put it up in here into the equation for x. So we get x equals 4 minus 2 times 1/2. So 4 minus 1 is 3. So the answer for this one would be the point 3 and 1/2. And make sure you put them in the right order. So we're getting either x or y by itself. Okay. Solve them for them if you need to. And then plug them into the other equation for that variable and solve. That gives you either x or y. Then once you've found that one, then you have to find the other one because we're looking for a point. So you have to find the values of x and the value of y so we know where these two lines intersect. All right, so do both of these. Another method for solving the systems of equation using elimination. What does it mean to eliminate something? Get rid of it, okay? So we want to make it so that we can get rid of either x or y so that we can solve. And it really doesn't matter which one it is you do, okay? It's your choice. So here we have 3x plus 2y equals 4, and 4x minus 2y equals negative 18. And so what we're going to do is we're going to add going down, and we want to make it so when we add going down, we eliminate x or y, which means then that either we want the x's to have the same coefficient, one positive, one negative, or the y's have the same coefficient, one positive and one negative. So if you look at this one right now, okay, do either x or y have opposite coefficients? Okay, the y does. This one has a positive 2y here, negative 2y here. So when I add these, okay, I'm going to get 0 for the y will be eliminated, and I just have x. So 3x plus 4x is 7x. 2 minus 2y is 0, so that's gone. And 4 minus 18 is negative 14. So we divide them both by 7, get x equals negative 2. Now, in using elimination, it's usually easier to get to the first variable, or the first answer, x or y, but then the second one's a little bit harder. Where substitution, sometimes the first one is harder to get the answer to, but then the second one is easy by plugging it back in. So now, once I get this negative 2, I can put it into either equation, it does not matter which one, to find the value for y. So basically this then just becomes your choice. Do you like the first one or the second one better? Doesn't matter. So I'm just going to use the first one. So I'll put negative 2 in for x. And solve. So we get y equals 5. So my answer is the point negative 2, 5. And your answer is always a point. Okay? You're not just saying x equals and y equals. You have to write it as an ordered pair because it represents a point. So for the elimination method, we want either x or y to have opposite coefficients. And then when I add going down, then I can eliminate one or the other. Yes, sir? There's going to be some that say use substitution, some say use elimination, there's just some just say solve it. And so you have to determine which one would be easier. Or just use whichever one you want. Yes? Yes. I will. Okay. All right. So let's look at another one. All right, so here's our steps. We look at them first of all. Do x or y have opposite coefficients? No, they don't. Okay? So then we're going to get x or y so that they have the opposite coefficients. Then once we do that, we'll add the equations and solve, and then find the other coordinate. Okay? And then always check your answer. Right? Should go back and check them. Now, so I can do either x or y here. Okay? And remember that to make them the same, okay, that means I'm going to have to multiply either one equation or both equations by some number so that they are. So they do have opposite. So when you get into a situation like this one, you have to just pick, okay, do I want to make the x's the opposite or do I want to make the y's the opposite? Okay? Sometimes one of them is going to be obvious. Okay? In this case, you basically have to pick which one you want. Okay? All right, so Carolyn wants to get rid of the x's, so we're going to choose x. So that means I need to make the 3 and the 2 so that they have opposite coefficients. So what's the least common multiple for 3 and 2? 6. So I'm going to multiply this one by 2 and this one by -3. Okay. All right. Because one of them's got to be by a positive, one's got to be a negative, so that they're the opposites then. So equation 1 now becomes 6x plus 10y equals -32. And remember, we're doing multiplying everything by that number. The second equation becomes -6x minus 9y equals 27. So step 1 is finished. I've got x or y with opposite coefficients. Now for step 2, we're going to add the equations together and then solve. So 6x minus 6x is 0. 10 minus 9 is 1. So this one turns out pretty easy there. We get y equals -5. Okay. So now we're going to take that -5 for y, and we can put it in either one of these two equations and use the originals. Don't use the adjusted ones. Use the original equations. So you can pick which one you want. I chose the first one in the previous example, so I'm going to do the second one this time. So we get 2x. Oops. (2x) plus 3 times -5 equals -9. And so now I'm going to solve this equation. So we get x equals 3. So my answer is the point 3, -5. And I can check them real easily. Okay? 3 times 3 is 9. And I'm going to go to, since I used 2x plus 3y, I'm going to go to the other equation and check to see if it works. 3 times 3 is 9. 5 times -5 is -25. So 9 minus 25 is at -16. Yes. Okay. So I did it correctly. All right, if we went back up here and checked the other one with -2 and 5, we use the top one, so check it with the bottom one. 4 times -2 is -8. -2 times 5 is -10. So -8 minus 10 is -18. So that checks also. So you should check them. So we're looking to, we want x or y to have opposite coefficients. Add them together, which will eliminate either x or y then. Then once we find that one, plug it into one of the two equations. It's up to you which one. And then that gives you your answer as a point. Now we're going to look at identifying the system. So is it consistent or inconsistent? If it's consistent, is it dependent or independent? Okay. And if it's inconsistent, then okay, that's all it is. Right? So yesterday we looked at the slopes. If the slopes were different, then it was consistent and dependent. Right? Or consistent and independent, we had one solution. If the slopes were the same and the y-intercepts were the same, we said it was consistent and dependent, which meant that there was an infinite number of solutions. And then if the slopes were the same but the y-intercepts were different, we had parallel lines, so then we had no solution. Well, we're going to use elimination then today to do it. Now we have two different things that could happen with elimination. That we can get an identity, such as 0 equals 0, or we could end up with a contradiction, which is what we had on the test yesterday, or on Friday. There was a couple different problems that were contradictions. You couldn't do them, so there was no solution. So we're going to use elimination to do this, to classify these systems and determine the number of solutions. So if we end up with 0 equals 0, it's an identity. There's an infinitely many solutions. And if we end up with two constants that are equal to each other that really aren't, then we have a contradiction. Now, one thing you got to pay attention to is notice that, look at these two equations that we're going to work with. Okay? All right, the x and y's are not in the same order. All right, so the first thing I might want to do is switch them around before I do anything else. So I always put them x first and then y. Okay? Now, the x and y's, I'm looking for them to be opposite signs, okay, for the coefficient. So which one do you want to eliminate here, x or y? Okay, eliminate the y. Okay. So that means that I'm going to multiply the first equation by -2. So that I have -2y here to go with my positive 2y. Okay. So I'll multiply this one by -2. So we've got -6x minus 2y equals -2. And 6x plus 2y equals -18. Yep, so we're doing elimination today. Okay, yep. All right, so what happens when I add them together? Okay, we get 0 on the left and -20 on the right. Is that a true statement? No, okay. So this is a situation where we have a contradiction. So what do you think happens with those two lines then? Would that be the same line, or would it be parallel lines? Okay, parallel lines because there's no solution. So in this case, this would be an inconsistent system, and there's no solution. Okay? When there's a contradiction, they're inconsistent, and there's no solution. If they were both sides went to 0, okay, then you would have the identity here, which would tell you then that there's an infinitely many solutions, and that's when there's the same line. Okay, it would be the exact same line. All right.